Problems 4 through 6 are going to give us a glimpse into some of the issues that can show up when you're working with the law of sines. So we just saw in the last problem that it's possible to be given characteristics of a triangle that don't actually create a triangle. So we have to be careful when working with the law of sines, whether we actually want to have a triangle or not. And then you're going to see in these next couple of problems that some other interesting things can occur. So let's go ahead and take a look at this triangle. Now I'm just going to draw out a generic triangle just so we can label. Oops. Let's erase that. Let's try it again here. Got caught on my straight edge. Okay, so I'm going to pretend like it actually does make a triangle, and we'll see if it does or not, or if there's any other issues. So here's my alpha, side length 2. Here's gamma and beta. So here is a side length of 4 because C is across from gamma. So we have to use these two sides here. Or I should say these two sides. This side and this angle first, because those are the only two that we have across from one another. So we're going to say the sine of 30 degrees divided by 2 is equal to. Now we either have to find beta or gamma. So here we're going to go with gamma because we have a side length for C. So this is going to be the sine of gamma over 4. So let's keep going here. So let's keep working here. We've got the sine of 30, which we know is 1/2. So this is going to be 1/2 divided by 2 is equal to the sine of gamma over 4. 1/2, let's do this as a side note. 1/2 divided by 2 is the same as 1/2 times 1/2, which is 1/4. Multiplying both sides by 4 tells us that the sine of gamma has to equal 1. So what we're looking for is an angle, gamma, whose sine value is 1. So if I take the arc sine of both sides, I have the arc sine of 1 is equal to gamma, which says find me an angle, give me an angle whose sine value is 1. Now let's just take a look here. If you remember, here's our unit circle. Arc sine is only defined in quadrants 1 and 4. So in quadrants 1 or 4, where is the sine value, the height, equal to 1? Well, the answer is right up top here. Okay, and that's going to happen at 90 degrees. So what I get for an answer over here is that gamma is 90 degrees. Now we can do this in our calculator as well. So let me clear this. And I'm going to ask, I wonder if I have to hit this. Yep, there we go. So I've got a value of 1, and I want the arc sine of it, and it's giving me 90 degrees out, which is the angle that we just found. So if this guy here is 90 degrees, then we can easily find out what beta is, because all three have to add up to 180. So beta is a 60-degree angle. Now the last thing I need to know is what is the side length B down here? Well, again, we can use the law of sines and go through and calculate. Okay. So we'll just go ahead and set up. One of the nice things here is I know that this is a 90-degree angle, so the actual triangle, is a 90-degree angle, so it doesn't look like this. Okay, but again, this is just to get an idea of where the side links and stuff go. So I'm going to go back to my original. I'm going to say, okay, the sine of 30 degrees over 2 then is going to be equal to, now beta is 60, so the sine of 60 degrees over b. So solving, I get b is equal to 2 times the sine of 60 divided by the sine of 30. So we'll take, clear this out, we'll take the sine of 60, we'll multiply that by 2, and we'll take that number and divide it by the sine of 30. And we're going to get 3.46. Another way to look at that, besides doing this down here, is to draw out our triangle now so that it actually does look like a 90-degree angle. And this is 30 degrees. This is 60 degrees. So here's my 2, here's my 4, and the question is, what's this length down here? Well, we can go ahead and solve this. If we divide everything, well, probably the easiest way to do this is just to say, okay, if I want this side, which is b up here, I want the cosine of 30, the cosine of 30 degrees is equal to b over 4. So 4 times the cosine of 30 would be equal to b. So if I take 4 times the cosine, we'll do it this way, cosine 30 times 4, and that gives us our same 3.46 value. So I didn't need to use the law of sines down here in the bottom, but it's probably just as easy to do so.